In section 5, we're going to look at both a rhombus and a square. So we're going to look at recognizing and applying properties of a rhombus and a square, and then we'll determine whether quadrilaterals are rectangles, rhombus, or a square on a coordinate plane. So what is a rhombus? A rhombus is a parallelogram with 4 congruent sides. Notice that we are still classifying a rhombus as a parallelogram. This time, instead of having 4 right angles, though, we have 4 congruent sides. So within my quadrilateral tree, I'm going to fit a rhombus right underneath of a parallelogram. Okay, because that's how we defined it. I'm not going to fit it underneath of a rectangle, though, because we don't know that the diagonals are actually congruent in this case. We do know that we have all 4 congruent sides. So going back, there are some other important properties that you will need to know as well. So 4 congruent sides is one property. Another property of a rhombus is that your diagonals are perpendicular. That's a really important one. Notice in here, segment AC is perpendicular to segment BD. Okay, so your diagonals are perpendicular, meaning I form right angles. Another important property is that your diagonals are going to bisect each angle. In other words, it's going to cut them straight in half. So as you can see here, this first diagonal, PR, is going to split this angle P into 2 congruent angles, meaning angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. In fact, all 4 of those angles are congruent. 1, 2, 3, and 4 are all equal. Likewise, on your other diagonal, angles 5, 6, 7, and 8 are all equal. So we're going to try and use these properties. So for example 1, letter A, you know that you have a rhombus, and it tells you that angle FJH is 82. So FJH, that's this one, we know is 82. It wants us to find the measure of angle KHJ, which is KHJ, that's this one. Well, specifically, we know that we have right triangles in here. I'm going to outline the triangle that we're going to use. That would be this one. So instead of using 82, I'm going to cut that in half. That way I know that I'm dealing with this angle right here being 41 degrees. I can now take and know that all 3 angles in a triangle add up to 180. So I'm going to take 180 minus 90 minus 41, and that would get us 49 degrees for angle KHJ. The next one, letter B down here, is dealing with some side lengths. So I'm going to erase all of this. It tells me that GH is x plus 9. That's this one. And we know JH is 5x minus 2. For our definition, we know that all the side lengths are equal. So we're going to take x plus 9 and set that equal to 5x minus 2. I'm going to solve, subtract x over, that gets me 4x. Add 2 over, that's going to get me 11. And then I'm going to divide. You can either write this as a decimal or just keep it as a fraction. Either way, it's going to be fine. 11 fourths, or it would be 2.75. Either's fine. I got some more down here at the bottom. Letter A. This time it tells me that FK is 5. FG is 13. It wants us to find KJ. This one's a little tricky. You would want to know that KJ is actually equal to GK, and that you are dealing with a right triangle in here. To find the third side of a right triangle, you would use the Pythagorean theorem. So In this case, a squared plus b squared equals c squared. Your c is 13. So I'll go 5 squared plus, you can call it anything you want, x squared equals 13 squared. 25 plus x squared equals 169. X, or kj, would come out to a length of 12 when you're done. And then your last one, I'll do 1b as well, because it's still all different. This time it tells me JFK. JFK, that's this one, is 6y plus 7. And KFG, that is this one. We know that the diagonals bisect our angles, which means then that these two angles are equal to each other. So we're going to go 9y minus 5 equaling 6y plus 7. I'm going to subtract 6y over, that's going to get me 3y. I'm going to add 5 over, that's going to get me 12. So y is going to be equal to 4 in this case.